everyone. July the 3rd. I think today is probably the first time in a very long time that I did nothing but read the whole day. It was great. Felt great. Just finished up a book. It's a good experience. Like, everything feels good. Very glad that I took decision to, like, I worked a little bit late last night just to make sure that today it's just fully enjoying this. So yeah, it was great. It was a little break from the monotony, actually, of the daily things. Yeah, it was all right. I think tomorrow will be another day of reading because I'm gonna pick up another book, which is also, I think today's book was how many pages? 500 something. I finished in a week. Tomorrow I'm gonna read Michael Law's book, Strangers in the Land. It's about Chinese Americans. Yeah, history of Chinese Americans, exclusion, belonging, and the epic story of the Chinese in America. Going back to see how it's actually part of this history that I was never taught. Right, I was never taught in school. Never really see anything like this, so it's good to know. All right. For crying out loud, we have another hard problem today. It's just like easy, hard, easy, hard, easy, hard. Wow, it's just... Or anyway, we still haven't found a better solution for this, so we need to think about this one too. All right, find a case character in string game. Is that the one that we did yesterday? I was wondering. I don't remember what we did yesterday. Alice and Bob. Yeah, this is a similar problem, right? Alice has a string with A, and given a positive K, also given the integer array operations, where operation I represent the type of the ith operation. Now Bob will ask Alice to perform all operations in sequence. If operation is 0, append a copy. If operation is 1, generate a new string by changing each character in word to its next character. Okay, so yesterday's problem was just changing, right? It was just changing. I don't have to do anything else. But today, you have to go through two different types. One is not changing, the other is copying. Return the value of the kth character in word after performing all the operations. So it's also different because this only difference is you now including. So like if everybody is 1, then it's the same thing, but it's not. So you have to consider that you start with A. You always start with A. Then the first one, you do a double. Right, and then I wonder. That's what I wonder. So yeah, you do a double. So it will be. Hold on. Let me try this one. This is just a triple because everybody is 0, so it's this. So all right. So step 1. Right, we have 1, 2, 3, 4. Actually, it's not 1, 2, 3, 4. It's just a rounds, right? So we have A as first round, and then we got AA, right? And then we double, right? Because this is a 1. So the first step, first operation, the second operation is going to be AA and BB, right? A third operation is just a copy of themselves. And fourth operation is this. So BBCC, BBCC, right? And then we're asking for the 10th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 10th, right? Which is a B. So following from yesterday's idea is we have these things. This is 10, right? And we basically did 2 copies, right? Did 2 copies, so you do 2 times. So that's why yesterday, I think it's, we have a similar yesterday for this, right? Yesterday, similar for this is, 10 is a C because you have to go two times, right? So A you go to B, B you go to C, right? That's what we did yesterday. So today is different because the step itself. So what's the step itself? So apparently we have to do this step. This is 1 step, 2 step, and a 3 step, right? Which corresponds to, but in reality it's just corresponds to this. It has 3 steps, right? Corresponds to this has 3 steps because we got this copy, that's 1 step, and it's copied from this one, right? This is the last step. And no, not really like 3 steps. It's 2. It's two steps. So we count the number of this because these are all the steps. That's from yesterday's analysis, right? These are all the steps. So yeah, this is the top one, getting to here, right? Because it's directly coming here. And then it's 2. Oh yeah. That's what it is. So we remove, yeah. So it's because this one's first get removed. This give you 1 step, right? Step 1, first step, and this is actually give you the second step. And the first step is a 0, and the second step, that's not the second step though. That's not the second. So you need to find which step it is, right? You need to find which step it is that, resulting in this. So you're on the 10th, right? On the 10th. So based on what you are, where you are, can you estimate at which step that generates you? Right? That's what we need. Like, we know how many steps, but we just don't know which step corresponds to. Like, this step doesn't really affect. This step doesn't really affect. It's this step that affects, right? So we want to know which step corresponds to you. And to do that, right, we need to know at each step, what's the number after you handle this step. So at each step, so we have 0, 1, 0, 1, right? So at this step, we'll generate 2 to the 1 total. There's 2 to the 2, 2 to the 3, and 2 to the 4, right? Let's see, operation. How long is the operation? Operation is 100 in length, but it doesn't really matter. What does it? No, it doesn't matter because we can find for 10, right? 10 is 2 to the 4. No, 2 to the 3. Between 2 to the 3 and 2 to the 4, right? Which means, so if we do log 10, this will give us 3 point something, right? So we know it's at, actually it's good because 0, 1, 2, 3, right? It's at the fourth step, right? It's at the fourth or index 4. That's the step that we generate this one. So we do that. So we know it's a 1, which means if we go, which means that we at the end that step is give you a 1, and then we get rid of this, and then what? Then we need to know the previous step, right? Well, that's fine because this is the first step, right? This is the first step. That's a 10. Well, actually, it's an 8, right? It's an 8. So what we do is we remove this, right? We remove this. So it comes back to the original idea. What's the highest number of bits? Right? The highest number of bits. Maybe it'll be easier to analyze it. Maybe it'll be easy to lay it out, right? Lay it out, and then I know this, how many zeros, right? This is how many bits. So I have like 3, I have 4 bits, right? 4 bits or 3, so it has to be a 1, which is the last step. Last step is 1, and then get rid of it, find the next one, right? Find the next one, and this is 1, right? Because this is 1, 2, 3. That's a 3, so we go to this, and this is not really a 1. This is a first step. See, that's the thing, right? You have to know, because if there are more 1s left, so we can count the number of 1s, right? So if there are more 1 left, then you will do the number of the zeros, and that will give you which position it is. But if it's only 1, it's like no more 1 left, right? No more 1s left. And then you have the number of steps. This is the number of zeros, right? So it's 1, 0, which means it takes 1 step. But if it's like 1, 0, 0, that's 2 steps, right? Because that's 4, which is you have to go to 1 step, right, and a 2 step. All right, 2, 4, you have to go 1 step and 2 steps. So that's number of zeros. So this tells you 1 step. 1 step. Right, which is just the first step. So basically, it's going to be a... So can we go right to left so we can like kind of handle it? So yeah, we go through this to know how many steps we've gone through. So this one will say we have gone through 1 step. So step 1, right? So we can say operation 0. That's the first step, and then we'll eliminate this. Not really eliminate. We just go. So we go all the zeros. 0, 0, 0, 0. Boom. First one. We count number of zeros, right? And then we go find a 1. Right, we find yeah, we just go right to left. We find the first. Every time we find 1, we find out how many digits, right? How many positions we moved. If there's been no before, no 1 before, then you will just go through this to create what's the current, And then when you find the next one, then we will count how many zeros and then give you which position it is. And then just keep moving until you hit. We can just, we need to have a count. Okay, so let's try this. What's this? 3307. So this solution builds on top of the solution for problem. What was yesterday? 3304. They skipped the intermediate one, right? I think they skipped the intermediate one. Oh, they did not skip the intermediate one. There's no intermediate one. All right, 3304. Right. We turn k into a binary number, right? We count from least significant bit to most significant bit. The initially, before the encountering of the first set bit, the number of the initial zeros represent the number of steps, right? Represent the number of steps taken, and we can get the operations, right, directly from operations array. After the encounter, of the first set bit, the next set bit signifies another change, right? Another change in letter. The operation for that is determined by the number of bits, the number of total bits encountered so far. And well, we do this until k is exhausted. So what we have is char arrest. We'll start with 1, and then we'll say int bit count. Okay, bit count with 0, and say while k is larger than 0, right? And we have bit count and not really bit count actually. So set bit, in the boolean, set bit encountered, right? So it will be false. And then this is int bit count, right? Count is 0. All right. So here, so we'll say bit is k and 1. There's the first bit. So count plus plus, right? And we have the first one. Actually, hold on. So we are here, right? And we need to determine if it's a 0 or not. So we got a bit, right? So we say if b is equal to 0 and not set bit found, right? When that's the case, when it's a 0, it's a not set bit found, res your plus equal to operations operations count. Right? That's the step. That's the step we do. Right? That's the step we do. And else, if bit is equal to 1, see, if bit equal to 1, so hold a second. I think it's very important. If set bit encountered or set bit not encountered, I think these two are very different. So if set bit encountered, okay, I would say if bit is equal to 1, right, is equal to 1, then we'll say res plus equal to operations what? So we have the count bit, so it's just a count, right? We'll do the count. And if it's a 0, we just ignore it. Else, if b is equal to 0, then res plus equal to operations count. And then we always update the count. Does that make sense? So when we start, if encountered, if not encountered, if this, and if b's else, right, then we say set bit encountered equal to true, right? So initially, every time we encounter 1, we'll update. Count is 0, count is 1, count is 2, and then when we hit the first one, then we don't do anything, but we'll set the bit. And then we have the set bit, so every time we hit, so just in this case, we will do the first operation, which is a 0, and this will set the bit, and this doesn't do anything. And when we hit here, right, because when we hit it, we haven't incremented it. So when we hit this set bit, which is bit encountered, and this, so count is equal to 3, 1, 2, 3. That's why we do the third one, and then we'll update. So at the end, we'll return res. All right, let's hope that this one works. Cannot do that. Okay, so maybe I can do that. Maybe there's no plus equal. I don't understand. Does the count go beyond? Oh, shoot. I forgot to do one very important thing. Every time we do, K need to left shift. No, right shift. My bad. Right shift. Yeah, sorry, I forgot K need to right shift. That looks promising. Let's try it. Wrong answer. See, we passed 900 and then we fail at one of them. I wonder if there is some sick joke that's being played on this one. What in the hell? So basically I change 1. Oh, wait, hold on. 1, 2, wait, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. Did you forget to wrap around? Anyway, why don't we do the other steps, right? Steps. And instead of doing this, we say steps equal to steps plus this, mod 26. I do think this is a better one. And then at the end we can just say, let's wrap around. So we say A plus steps. Don't know, but we can always try to see if this one solves the problem. Yep, I don't know what happened here, but something is wrong. Yep, that's it. So solving yesterday's problem is the key to solve today's problem. I'm very glad that we figure it out. Yeah, apparently 0 milliseconds for sure. Yeah, apparently. Alright, solving yesterday's problem is the key to solving this one. One of a rare case, right, where we can really celebrate. But I still don't understand. Well, apparently it's not 14 because every time I shift, right? I shift. Why would it become empty? Good question. Why don't you try the steps? Well, the steps would tell you a very low number. But I don't understand. Right? There's only 14. I'm just curious now. You can say that I am very, very curious because I want to know. Right, everything else is the same, and yeah, we can return full, but I want to print out full every time. Plus, let's only use the last one. Just, take a look. I'm curious. Huh? Why I have these things? What in the world? How many times I go through? Oh, right shift. Oh, I see. Oh my god. I thought we're right shifting on this thing. No, we're not right shifting on this thing, dude. Ah, that's why. Makes sense, makes sense, makes sense. Yes. This is the one. This is the one. Yeah, I just completely forgot that that's the way. Okay, yeah, that'll be it. That's not too bad. You just figure out. Of course, they have their way of doing it. I have my way of doing it. I like my way. But it's essentially the same, right? It's essentially the same. Mathematics. What's POTD? Of the day. Problem of the day. Oh, anyway.